Thank you, Ms. Zhang. Good morning, good afternoon, and good evening. Welcome to the webinar hosted by SPTL. In today's webinar, I will guide you through the essentials and updates of IM in China with a snapshot of patent eligibility of IM-related solutions and share with you latest cases and practices in China. 5 parts, as you can see, are gonna be shared in this webinar. First of all, let's have a look at what intelligent manufacturing, called IM for short, is. The concept of IM was first created and advocated in the classical work named Manufacturing Intelligence, the first monograph in the field of intelligent manufacturing research, authored by Wright and Bourne in 1988. In this work, IM is defined as a manufacturing technology by which small batches could be produced without manual intervention by a smart machine, which features using smart techs like integrated knowledge engineering, manufacturing, software, robot vision, and so on and so forth. However, as science and technology advances rapidly, with imbalanced development among countries and districts worldwide, scientists as well as policymakers of each country or district have already refined and will continue refining the concept of IM since it was put forward. Taking my country, China, for an example, a concept defined in National Standard Framework Construction Guideline for IM, version 2021, and adopted in a book named Industry Patent Analysis Report on Intelligent Manufacturing, written by CNIPA academic committee, is shown on this slide. From this definition, we can learn that IM is a technology based on the deep integration of new generation information tech and manufacturing tech. We can learn that this technology relates to not only manufacturing activity in narrow meaning, but also design, management, service, etc. Which means IM is the one running through design, manufacturing, traditional management, service, and other process. For your information, an overview of IM is presented here. Since literal interpretation just now seems kind of abstract. As we can see, the so-called new generation information tech mainly includes, data techs. For example, Internet of Things, microelectromechanical system sensor tech, and big data tech, etc. It also includes computing power technology. For example, cloud computing, edge computing. It further includes algorithm. For example, algorithm relating to artificial intelligence, relating to digital twin. Moreover, gradual evolution of communication technology. For example, the well-known 5G tech, with full name being the 5th generation mobile communication technology, RFID, etc. These communication technologies accelerate the integration of manufacturing tech and information tech, so that the attention to this kind of tech should be also paid. From the hierarchical architecture of IM system describing 3 dimensions, namely system hierarchy, life cycle, and intelligence characteristics, IM can be roughly divided into 6 main tags. That is, smart equipment, also called smart device, smart factory, smart supply chain, smart service, smart empowerment, and industrial network. Here, from a personal perspective, for innovation entities, please do not only pay attention to entities such as equipment, device, or system, but also have a look at and show interest in integration technology, such as smart factory, smart supply chain, and smart service, since the latter may be more worthy or more profitable to some extent in a particular manufacturing activity. For patent attorneys, please also keep an eye on integration technology, because it may help you establish a more complete and effective patent portfolio for your clients. All right, let me first make a further introduction to smart factory. As you can see, smart factory technology can be mainly categorized into design, product, management, and logistics. For each one, a further categorization could be established as shown on this slide. For smart supply chain, it could be mainly divided into construction, management, and assessment. And for smart service, it can be categorized into customization and maintenance. All right, with regard to what IM is and its classification, I believe now we are on the same page with CNIPA. Let's move forward to the next part. As we all know, a solution should meet several criteria so that it could be considered as an eligible subject matter. In other words, a technical solution in the meaning of patent law. For patent eligibility of IM-related solutions, among these criteria, Article 2.2 and Article 25.1 are something worth thinking about and worth talking about. According to what is stipulated in Article 25.1, for pure use and methods for mental activities, no patent right should be granted. As is further provisions in China Patent Examination Guidelines, for method for building up a mathematical model with no technical features, and only based on abstract algorithms, no patent rights should be granted. In contrast, if a claim includes technical features in addition to algorithm features or business rule and method features, it is possible to be granted. I believe these provisions quite make sense, since the market would be monopolized if a purely theoretical solution were protected by patents. Then, how about Article 2.2 and its further provisions in guidelines? Let's have a look. According to Article 2.2, invention means any new technical solution relating to a product, a process, or improvement thereof. But please pay attention to what is stipulated in Section 6.1.2, Chapter 9, Part 2. In guidelines, it says that if each step relating to algorithm in a claim has close relationship with the technical problem to be solved, it is possible to be granted. Someone may ask what close relationship means. Actually, to accomplish the so-called close relationship, two requirements should be satisfied with accordance to the provisions in this section. Let's have a look. As the first requirement, the data to be processed by the algorithm should have clear or definite technical meanings. As another one, the execution of algorithms should be directed to laws of nature. It seems quite clear, or it seems clear literally, but I'm afraid some of us may be at a loss to encounter the case in which the problem claimed in the description relates to algorithm itself, while it is described that data to be processed by algorithm is the ones in some technical fields or in the form of technical ones. I'm afraid some of us may be also at a loss to encounter the case in which the problem claimed to be solved is the one in a specific field, while how the algorithm is applied is not mentioned in either embodiment or claim, or only the source of data to be processed by algorithm is mentioned in the description. In each case above, it seems that two requirements both are literally satisfied. But some of these solutions finally stood rejected as not being eligible ones by examiner. Thus, it seems essential to have a deep understanding of these two requirements in order to arrive at a correct judgment, a correct draft, and a correct examination. Seeing is believing. Let me introduce two typical cases. From these cases, I believe we can learn how to draft an eligible IM-related specification. Okay, let's see the first case. As the first case, its name is BP and PSO-based data prediction method. Please let me briefly introduce BP neural network and PSO. Although they are familiar to people with mathematics or computer science background. BP neural network, with full name being backpropagation neural network, is a multi-layer feed-forward network trained according to error backpropagation algorithm, and it is one of the most widely applied neural network models in machine learning field. PSO, with full name being particle swarm optimization, is one of the bio-inspired algorithms, and it is a simple one to search for an optimal solution in the solution space. Okay, let's come back to this case. In background part, it is described that an optimized hybrid prediction model of PSO and BP neural networks has been widely used in order to realize the real-time matching and the intelligence response of energy supply and demand information. However, although this method can obtain a better network structure and a generalized population, the population size still cannot avoid the defects caused by PSO and BP neural network themselves. And oscillation and divergence still occurs. Moreover, calculation is still carried out only based on the average value without considering particularity of parameters where oscillations or divergence has arrived at a particular value. In order to solve this problem, a data prediction method based on BP and PSO is provided. The solution seems kind of complicated and obscure. So let's have a direct look at claim 1. Before that, I will give you 5 to 10 seconds to have a quick glance at this solution. Okay. Time's up. Let's forward to claim 1. Actually, as you can see, claim 1 is very informative. So I also do not intend to explain this solution in detail, but Please keep an eye on several expressions in red. It states in claim 1 at first that this method is provided for predicting power system load, which means this method is applied to a specific field. Then, totally 7 steps are stated to accomplish this method. However, in these steps, the algorithm is interpreted a purely theoretical way. Taking step 1 for an example, it says that the PSO parameters initialization operation is executed, and the training sample set is used to determine the network structure of BP. PSO parameters including the speed and the position of PSO particle swarm. However, as people with algorithm background know, the speed and the position of PSO particle swarm are purely mathematical definitions. Please allow me to read what is said in step 5 so that you can feel how abstract it is. It says that if the current number of iterations at the first time, using the preset inertial factor cycle to change formula so as to correct the inertial factor to obtain the inertial factor after oscillation is eliminated. Using the inertial factor after the oscillation is eliminated to update the speed and the position of the PSO particle swarm, and jumping back to step 2 after the update is completed. It sounds like a mathematical interpretation of a newly established algorithm in the midterm presentation of a student in mathematics department, isn't it? As a result, people cannot learn from this step how power system load is practically predicted by this algorithm. Additionally, in the description, steps of this method are also explained in a purely mathematical way. How to deal with power load data by this method is not mentioned at all. Okay, now let's have a look at how the examiner reviewed on this case. First, the problem to be solved is how to predict power load in background. It makes sense. Second, claim 1 claims a BP and PSO-based data prediction method. It also makes sense. Third, 2 technical features, namely a BP and PSO-based data prediction method for predicting power system load, and so as to predict the future power system load. In claim 1, clarifies the specific field, namely power system field. However, as explained just now, there is no technical correlation between specific process in claim 1 and the prediction of power system load. And claim 1 doesn't tell how to make use of this method to predict the power system load. Furthermore, this solution doesn't include specific parameters of the power system load. Thus, this solution is considered as not being the subject matter of patent coverage. Next, let's see a positive case. As the second case, its name is a training method for energy data prediction model. I'm sorry that I will read a long description in a very poor pronunciation, but it really helps you understand an appropriate drafting, so please enjoy it. So in background part, it states that in the energy industry, for the energy data prediction business, the accuracy of prediction tends to directly affect the business capability or business quality. As conventional data prediction, historical results and the corresponding historical multi-dimensional data are put into a data prediction model so as to make the model learn. After learning, a connection between the historical results and the historical multi-dimensional data is obtained. Thus, prediction could be achieved by means of these trained models based on new multi-dimensional data. However, the connection between historical results and historical multi-dimensional data is taken into account, while the connections among multi-dimensional data themselves are ignored. As a relative rough model training method, the training result will affect the accuracy of data prediction. So in order to solve this problem, a training method is provided. In this method, the autoencoder's strong ability to express implicit features of data and the extreme learning machine's characteristics of fast training, strong learning ability, and high precision are taken into account so that an energy data prediction model is formed by combining the autoencoder with extreme learning machine. Thus, implicit features between dimensions in multi-dimensional data could be used to predict energy data more accurately. Then, let's see how a claim is drafted appropriately. Claim 1 provides a method for training energy data prediction model. The method being used for predicting the power generated by solar PV. This method comprises several steps. Let's take step 1, for example. In step 1, it states that the first sample set selected from energy sample sets is used to train an autoencoder so that the trained autoencoder can output implicit features between dimensions in multi-dimensional data. Well, please pay attention to this expression. Well, the energy data sample sets comprise multi-sets of historical multi-dimensional physical data and historical energy data results corresponding to each of historical multi-dimensional physical data sets. With multi-dimensional physical data are the physical conditions for solar PV and the energy data results, including solar PV results. All right, let's skip the rest steps and see how the examiners review on this case. First, the problem to be solved is how to predict energy data accurately in background part, which is the same one as case A. Second, claim 1 claims a method for training an energy data prediction model. It makes sense. Third, in claim 1, how autoencoding an extreme learning machine algorithm applied to predicting energy data is clearly and specifically described. Further, in claim 1, specific parameters of energy sample data are clarified. Thus, this solution is finally considered as being eligible one for patent coverage. Okay, let's make a conclusion on how to determine the eligibility of an IM-related application. I believe this may also help drafting. First, whether the algorithm is applied to a specific field or not is determined. If the answer is not, you can say that the solution is not an eligible one. If the answer is yes, whether data have clear technical meanings or not is then determined. If not, we can say the solution is still not an eligible one. But if the answer is, go to the next step. In the next step, whether the integration of algorithm with data having technical meanings is deep or not is determined based on both claims and description. If not, the solution is not an eligible one as well. But if the answer is yes, the solution could be considered eligible. Okay, next, let's have a review on what the term deep means. If the following requirements are met, the integration can be considered deep. As the first requirement, the problem to be solved mentioned in the description is directly relevant to data having definite technical meaning. For example, energy data prediction is inaccurate since correlation among multi-dimension data is ignored. As the second one, there exists a particular technical connection or correlation between technical meanings in claims and the data having technical meaning. That is to say, how to process these data with algorithm is clarified. Also, it helps to understand better to see cases in which integration is not deep. For instance, in case that regarding the problem to be solved, the description only mentions that the algorithm can be applied to a particular field on multiple scenarios. Let's say only the statement like the invention has been widely applied to such fields as voice recognition, image classification, natural language processing, etc. is described. The problem to be actually solved is improving algorithm itself, because it isn't clear which technical problem in field or which technical problem in which field the invention on Earth aims to solving. For another instance, the integration is not deep if specification only mentions the source of data and the specific execution of the algorithm has no technical correlation with the source of data. In conclusion, if the solution relates to a specific field, in other words, the algorithm is applied to a specific field, the solution as a whole can solve the technical problem in the field with the algorithm features and each step of the algorithm can directly reflect the execution of the algorithm or reflect the adaptive modification of algorithm as being applied to the field. This kind of IM-related solution is eligible for patent coverage. Okay, let's move on to the final part. In this part, I want to share with you some trends in patent eligibility of AI-related solution in China. And the third proposed amendment to China Patent Examination Guidelines. It says that if a solution relates to an improvement on AI or data algorithms such as deep learning, classification, and clustering, and if there exists a particular technical correlation between algorithm and internal structure of a computer system, And if the solution can solve problems such as how to enhance the computing efficiency or execution effect, example, decrease data storage or decrease data transmission, improve processing speed, it could be regarded as an eligible one for patent coverage. It also says that in the case that a solution relates to data applied to a specific field, if the solution mines the intrinsic correlation in accordance with laws of nature by using algorithms like classification and clustering, regression analysis, or neural network. And if the solution can hereby solve problems such as how to improve the reliability and the accuracy of the data analysis on specific application field, it could be also considered as an eligible one for patent coverage. Actually, from my personal perspective, what I'm really looking forward to is with algorithm improvement related solution without any technical field could be eligible for patent coverage in China in the coming future. Since demand of innovation entities for protecting this kind of solution is increasing at a rapid speed, and several computer implemented methods relating to dropout algorithm have been granted in the US in the past few years. Okay, that's all I want to share with you this morning, this afternoon, and this evening. Thank you for watching and listening.
Thanks for your sharing, Mr. Shen Wang. Now let's go to the Q&A session. Here's a question from Mr. Yang. As mentioned at the beginning, intelligent manufacturing may involve scheduling or management in a factory, which may be controlled by human factors. But it seems that a technical solution should follow the laws of nature, right? Does it mean that human factors should be excluded from a technical solution? Please.
Thank you, Mr. Yang. Thank you for such a thought-provoking question. Yeah, right. Well, actually, from my viewpoint, it is not human being factor, but man-made factors that should be excluded from we say technical solutions. As far as I know, human beings, they have both subjective properties and objective properties. For example, 5 senses, that is to say, touch, sight, hearing, smell, and taste. But each one is associated with a particular organ. Let me take eye for an example. The wavelength range of visible light in a human eye, a human's eye, is totally different from that of the honeybee. Because the structure of human eye is totally different from that of the honeybee's eye. Thus, I think that objective properties of a person like 5 senses or as physiological properties may not be excluded Yes.
Okay, thank you. And we have a second question here, which comes from Ms. Lin. Is there any specific regulation in China focused on intelligent manufacturing related solutions, for example, in your examination guidelines or other documents? Please.
Thank you, Ms. Li. A very good question. But I'm sorry, it is a pity that there's no specialized regulation on such like IM related solutions or other kind of, I mean, industry related solutions. But as I shared, the solutions, IM related solutions, are deep integration of algorithm and manufacturing tech while communication technology, so that we can apply the stipulations of eligibility of computer implemented solutions, as I said just now, or we can say the stipulations of eligibility of algorithm related solutions to IM related solutions. Actually, as far as I know, there's no specialized regulations on IM related solutions, not only in China, but also in other countries like US, Japan, and Europe. But there are some alternatives, I think. For example, in US, Alice test is always adopted to determine patent eligibility of a solution, regardless of, or we will not, it doesn't matter whether it is a IM related one or AI related one or a business model related one. Yes, that's what I think.
Thank you for your introduction, Mr. Shenwang. It seems that there's no further question at this moment. Anyway, if anyone has further questions, please send your question by email to us. And actually, that's all for today's webinar. I hope the information just provided by Mr. Shenwang would be helpful to you and your clients. Thank you again for being with us. Please stay tuned to our further webinars this year. Have a good day, good night. See you next time.
See you next time.
See you.